Hi, my name's Danny Basler. I am a product marketer within Freescale's microcontroller product group, and I'm coming to you from the beautiful Bavarian mountains of southern Germany on a glorious sunny day, specifically to give you an update on a new demo that we've developed featuring our new Kinetis V-Series KV5x MCU based on the ARM CortexM7 core. The V-Series is Freescale's newest MCU family for motor control and power conversion applications, and the KV5x is the newest device within that family. It includes a number of other families that cover CortexM0 Plus and indeed M4 based solutions for other applications within motor control. So let me show you what the demo is. I'll just need to switch around the camera here. Okay, so here it is. As you can see, it is a drone or UAV demo. This particular model is from the company DJI, and it's the Phantom 1 version of their products. A very popular one in the market today for both hobbyists and increasingly commercial applications as well, such as aerial surveying of structures and farmland and things of that nature. So it's a good example of a multi-motor control design in a modern application. The existing design within the drone, or the old design, looked like this. If we can just show you here, it's a little bit flickery, but I'm trying to hold the camera straight. So you have a central flight controller which receives commands from the radio unit that the pilot would hold, as well as from the inertial measurement unit on board, which includes an accelerometer and gyroscope, and that provides the velocity and orientation information to the flight control unit. In turn, that communicates through a PWM-based modulation scheme with 4 embedded speed controller units, or ESCs. You can see here, if I zoom in a little bit, the existing PCB that was in the old design. So there are 4 of those, 1 for each brushless DC motor. Each ESC module contained one 8-bit 8051 MCU. As well as the 3-phase driver circuitry to support that. So that was the existing design, as I said. And what we have done at Freescale is we have redesigned the embedded speed controller part of the drone design, and it looks like this. So it's a single PCB, as you can see, and it features one KV5x MCU, as you can see in the centre there. It's a little bit blurry, I'll try and zoom back. In addition, on the edges are 4 of, as you can just see where I'm pointing, 4 Freescale GD3000 motor driver ICs as well. Those are replacing several discrete analog components. So we're removing 4 of the older 8-bit MCUs and replacing it with one single KV5x ARM CortexM7 MCU. We also have a CortexM4 based version of this design available using the KV4x family. So let me tell you a little bit about the hardware itself. So the KV5x MCU offers a number of advantages in this design. First and foremost is BOM cost. Removing 4 MCUs and replacing it with one offers a natural reduction in BOM cost and component count or component cost, as well as PCB layout and manufacture costs. Secondly is power consumption. Extremely important in a drone application is battery life. So naturally designers are keen to reduce in any way possible the amount of battery consumption within the device. So the MCU can help with that. Using a single MCU, of course, reduces the overall MCU consumption versus 4. In addition, you can desynchronize the 4 motors using the single MCU such that it reduces the overall loading on the battery, so there's another advantage for power in that as well. In addition, with one MCU you have improved safety functionality and power measurement. So for example, if there would be a problem with any of the props on board, any of the propellers on board the drone, which could potentially result in an unstable or unsafe condition, you can take appropriate action to either change the performance or speed of the other motors, or indeed return the drone to a safe condition and land it in effect. So yeah, those are just some of the several advantages that we can offer with this new design. In terms of the MCU itself and the hardware or parts of the MCU that are used, the 220 MHz CortexM5 core, CortexM7 core operates at about 50% loading, so there's ample performance available to implement additional functions on the design if necessary. We're only doing the embedded speed control, but what you could also do if needed is the MCU that's used in the flight controller unit centrally, this one here, could also be removed and replaced again by this single MCU, such that it's doing speed control and flight control functionality too. We also use, in terms of peripherals, we use two onboard flex timer modules on the chip. We use two 12-bit high-speed analog to digital converters, SCI, SPI, crossbar switch, which is a really nice feature that removes or reduces the loading on the MCU by allowing flexible triggering between external circuitry and the onboard analog and timing peripherals. And it uses about 76 pins within this 144 pin package that you see here on the design. So there's plenty of I/O as well available for implementing those other functions such as flight control that I mentioned. On the KV4x version of the design, it uses a 100 pin package and it requires approximately 99 of those pins, so there's slightly less room available for expansion, but it has more than sufficient horsepower or processing power to accommodate the needs of this particular application. So that's the KV5x MCU. As I said, the GD3000 components, which I'm just pointing to here with my thumb, there are 4 of those. So these are the pre-drivers and they replace several discrete analog components. What are the advantages of using the GD3000? You can, obviously BOM cost is one, but in addition the GD3000 includes fault monitoring and failure protection circuitry. So again, for drone safety, you have added safeguard in there, added redundancy. And also that particular IC can operate up to 58 volts, so for larger drones with larger batteries on board that require longer flight times, heavier loading, such like, then the GD3000 is an ideal solution for that. The KV5x MCU operates at 1.7 to 3.6 volts. It's essentially a low power MCU for motor control systems. So that's the hardware. The software is based on a Freescale brushless DC, sensorless brushless DC reference design. It's fully portable to not only drone applications but any other application that uses single or multi-motor control. So it's a really nice solution overall for both hardware and software. And again, it's just one example of the V-Series performing multiple motor control in a consumer or indeed industrial environment or application. So I'll just finish up with a short demonstration. Mention just about availability of the products themselves. The KV5x ARM CortexM7 MCU will be sampling in October of 2015 and will enter production in December 2015. The KV4x ARM CortexM4 MCU is entering production in October 2015. And if you need more information on this particular demo, we have an application note. I'll just kind of hold it up there, which is application note number AN5169, and it's titled 3-phase brushless DC sensorless motor control using the KV4x or KV5x in a quadcopter application. If you need more information, you can go to freescale.com/Kinetis/V-Series. Sorry, a wasp. Okay, let's do a wee demo. Okay folks, here you can see the drone is operational. It's running. The 4 brushless DC motors running each from one combined single KV5x MCU. So we're in a really good example of Kinetis and motor control applications. Due to the surroundings, namely some wildlife on the hillside here, as you can see, these guys, I'm unable to do a full flight of this, so what I'm just going to do is gently run up the motors so you can get a flavour of the operation. I can assure you it does fly very well, but because of the current limitations, I'm just going to do a quick sort of power up here so you can get a flavour of it. Okay, here we go. I'm just gently increasing the throttle of the drone, and I'm kind of holding one hand on the phone and one on the controller here folks, so this will literally just be a quick flash of a demo here. Okay.